A rock is dropped into a pool and it begins to create a circular wave. If the circle is moving outward at 6 centimeters per second, then determine how quickly the area is changing after 5 seconds. So we're given a rate here, and it is the circle is moving outward at 6 centimeters per second. So if we're going to illustrate this, this is where the rock is dropped, and then there's a circle that's moving outwards from that direction, from that point. Okay, and the rate at which this wave is moving is going to be a change in the radius. So the radius of this circle, we're going to call that r, and the rate of 6 centimeters per second is going to be dr dt, which is 6 centimeters per second. And what we want to determine here is how quickly the area of this circle is changing after 5 seconds. So we want to determine the rate at which the area is changing with respect to time when the time equals to 5 seconds. So the area of a circle is given by pi r squared. So we can go ahead and differentiate this expression. It's going to be dA dt, and the derivative of pi r squared with respect to time. Pi is a constant, so we can move it outside of the derivative, so it becomes pi times d dt of r squared. We differentiate r squared using the chain rule. The outside derivative will be 2 times r, and the inside derivative is going to be dr dt. So now our derivative is complete, and it looks as follows. dA dt equals to 2 pi r times dr dt. We want to determine the rate at which the area is changing with respect to time, and we know the rate at which the radius is changing, so that's the 6 centimeters per second. We don't know the radius at this point, but we can determine the radius because we know that we know the speed at which the wave is traveling, and we know that that we want to determine this after 5 seconds. So we can determine r by simply multiplying the speed at which the wave is traveling times 5 seconds, which is going to give us a radius of 30 centimeters. Now we can go ahead and plug in what we have. Two times pi times 30, dr dt was 6, and this is going to give us 360 pi, and this is an area, so it's going to be centimeters squared per second. So we can conclude that the area is increasing at the rate of 360 pi centimeters squared per second.